Hello everyone, today I'm going to show you how to define mesh interfaces in heat transfer problems, especially conjugate heat transfer when you have like fluid solid interfaces or different solid interfaces, how to create mesh interfaces to as a coupled walls in Fluent to consider the heat transfer between two materials during CFD simulations. So first I will drag and drop a Fluent simulation here, one block. So let's create a design modeler geometry. So what I will do, I will create two boxes inside together. The outer box will be air or fluid domain, and the inner box will be the solid domain. So first let's do on ZX, create a sketch, just a single box, doesn't matter the size, or so go to the modeling, extrude, so now we are going to create a bigger box in XY plane. I will create a sketch, another rectangular. So now I don't define the dimensions or every details. I just want to show you how to generate and define the interfaces. So I will do add frozen, or we can select from this and drop down menu. So now we have two overlapping volumes. We need to subtract the small box from the bigger box. So create boolean, subtract, target is the bigger box, the tool is the smaller box, preserve the tool body, yes, generate. So we have if we hide the inner box, we have a like outer box with a cavity. So as you can see, we have two parts, two bodies. Let's put the inner box and define as outer box. So show all bodies. So let's close design modeler and open the meshing. So here I will introduce three methods for defining the interfaces. So the first method will be the manual method, which is the most time consuming method. So mostly the preference is not to use this method because you need to define like specify name selections for the interfaces in the meshing, and then again create the mesh interface in the Fluent. So okay, now we have the geometry. You see we have two boxes here. So as you can see, there's no connection. So the first method is not using the meshing connection, but using manual. So one method, the first method is to select this inner box, hide body. So for the interfaces, we will have like we have they have 5 surface of contacts. The inner box is contacting the outer box from this 5 faces. So right click, define the name selection. Let's say interface underscore outer box. So let's show all bodies, then hide body, or you can select F9. So now we will select this 5 surface or faces, and not the bottom one but the up 3. Then create a name selection. Let's say interface underscore inner box. So let's define these as inner box, show all bodies, and we can press N to define the name selections, outer box. Okay, now we will just generate the mesh, because we don't want to do the simulation now, so I just want to show you how to do this. So we defined 2 name selections for the interface, the inner box and outer box as a volume selection as our zone. So update mesh. So I will close the meshing and open the Fluent. So I will just open it. Okay, now we have our mesh here. So if you go to boundary cell zones, the both inner box and outer box are fluid domains. So we need to define the inner box as a solid. Okay, so if you go to the boundary condition and group them by type, you will see that since we put the keyword interface, it identified these 2 selections as the interface. So if you don't put the interface, most of the time it will be wall type. So I will change the type to wall. You can select here and just change the type from this drop down menu. In this case, you can see we have boundary condition and nothing. The mesh interface option is disappeared from this simulation tree. So if we change this to interface type to interface, you will see that we will have this mesh interface here. So to define the heat transfer conjugate heat transfer interface, you need to double click on the mesh interfaces. We have 2 interface. There are 2 methods. You can just select these and create just put a name interface like and auto create. It will create interface 01, and if we close it, you will see that now we have interface and the interface shadow. So it created the same it defined a virtual wall or virtual interfaces around that inner box. So if you go, okay, let's first turn on the energy equation. So if you go to this simulation, you will see they are thermally coupled. Or if you delete this interface, so we have interfaces here, you can manually create the interface. So you can define a name, let's say interface number 1, and inner box and outer box, 2 sides of the interface you can select and collect as a coupled wall. So there are different types of interfaces, like periodic boundary condition. You can read the Fluent manual, or we will create some tutorials in like future videos. So then create edit. So it will do the same thing. As you see, they are like it's created two interfaces with the thermally coupled walls. So this is the first method, which is the most manually controlled method, and the slowest as simulation wise, because you are defining interface and coupled wall in Fluent, so it will a little bit slow down the simulation for the complicated geometries and problems. So let's share the same geometry with meshing. Okay, so I will open the meshing again and go through second method, which is defining the meshing, defining the interface using the ANSYS meshing. So let's start the meshing. So this method is good for simpler geometries, because for the very complicated geometries, when you have like two solids, or like two solids, there's a fluid between and there's a fluid outside, and sometimes it will not create the connections in a proper way. So you see here there's nothing in the connections. So for this one we have I will explain first. I will create a contact tool, then under the contact tool insert the connection group and create automatic connections, not contact tool, sorry. So if you see, it's manual, it's automatically defined like a contact for these regions, 5 faces, as you can see around this small cube, and 5 faces inside this. If you do the wireframe, you can see the same 5 faces we manually selected in the previous method. Here is selected by the ANSYS meshing and defined as a interface or contact region. So this is mostly the same method as the mechanical, because ANSYS meshing shares the meshing in the inside ANSYS mechanical. This is more common way defining the contacts in ANSYS mechanical. So here we end the outer box and F9 to hide this. Okay, hide body, and this one N or name selection inner box. So as you can see, I didn't define any interfaces here, so I will just again generate the mesh and show all bodies, update. So I will close this meshing and go to Fluent. Okay, here as you can see, it's automatically, if you define the inner box as the solid zone, so just click OK. So as you can see here, ANSYS mechanical, it creates the interfaces with the contact region, which is created in meshing automatically, and we have this shadow wall around that and wall and shadow wall around that inner box, and if we turn on the energy equation, we can see that they are thermally coupled. It's the same as it's the automatic way of creating the interface and contact, which we did in the previous method. So you can see there's a contact region here, and if we like edit here, you can see we have an interface. So if we like go to the boundary condition and right click on the shadow display, okay, because this is a interface, sorry, we need to display this interface. This is a walls around this inner cube, and there's the 5 walls as we had in manual mode. So this is kind of similar way as the first method or the manual mode, unless we are doing this the same way automatically. One point I need to emphasize here, ANSYS Fluent, ANSYS meshing, if you go to ANSYS workbench options and go to meshing, there is an option or check mark, you can see auto detect contacts on attach. So let's test this one first before going to the third method. If you reset the meshing and reset the Fluent setup, so as you can see, this check mark for the meshing is not checked. So when previous time when I opened the meshing, there was no contact there. So I will check mark this one and okay. So if I open the meshing, you will see that it's going to create the contacts automatically. We don't need to create the contact groups and just ask it. So if you go to the connection, you see that it's automatically created the contact. So, but for complicated, as I mentioned, for complicated simulation, it's not a good method of creating or defining contacts. So I prefer not to check mark this one, so I can manually define the interfaces. So the third method and most convenient method that personally I use in my simulations, I will create another block, share the same geometry. Oh, let's just copy this block, because I want to edit the geometry in the design modeler, so I don't want the same exactly the same geometry. So I will reset meshing. When you reset, it's like it will clear all the data and all the settings and all the work you have done on the meshing and the part you are resetting. So I will reopen the design modeler. So in this case, I'm trying to create interface from the geometry. As you can see here, we have 2 parts and 2 bodies. So if I select 2 parts and form new part here, so I defined both of these boxes as 1 part. So if I close the design modeler and open the meshing, Okay, as you can see here in the connection parts, we don't have any connections, and we will not, let's generate the mesh, we will not define any, we will not select and define any surfaces as the interface. So let's name selection outer box, hide this body, and inner box. So show all bodies. As you can see in the name selection, we have only the volumes, which will be the zones. So I will update the mesh. So I will close the meshing and open Fluent. As you can see, I don't go through the Fluent settings because I'm not planning to do any simulations. I just want to show you how to create the interfaces. Okay, so now we have our mesh here. Let's turn on the energy model. So so now you can see in the boundary condition zone type, we have walls of the inner box and walls of the outer box. So let's display these walls display. You can see this is the walls of the outer box, and also walls of the inner box. Okay, so let's display the mesh here. So we don't have any mesh interface and any interface type boundary selected here. So, and the both inner and outer box defined as fluid. As at the moment we define the inner box as solid, and click OK. It will create the interior, the wall named interior, and it creates the inner and outer box with the shadow. In this case, you can see that there's no mesh interface in the Fluent, but these two walls, they are thermally coupled with each other. Like we have thermally coupled this one here, and with this like shadow wall. So this is thermally coupled automatically. So if we want to display these walls, you can see that the same 5 walls we defined manually or automatically as the interface are defined as these interface walls and shadow walls, which are thermally coupled. So if you run the heat transfer simulation, they will consider it as coupled wall, and it will be a conjugate heat transfer problem. So thank you for watching this video. If you have any questions, please leave your questions in the comments part. Also refer to the description of the link in the description of this video for the link for the conjugate heat transfer simulation with Fluent. And please subscribe to our channel, like our videos, and again, if you have any suggestions or if you want to have any specific kind of tutorial, please send us in the comments, so we will try to